All right, let's have a look at the last part of the topic vectors. In the previous videos, I treated how to find the resultant of two vectors under two different cases. One, two vectors that are perpendicular. Two vectors that are at a particular angle to each other, but that angle is not 90 degrees. Today, we want to have a look at, and also I treated two or more parallel vectors, how you can find their resultant. But today, which is the last part of this topic, vector, we want to have a look at how we can find the resultant of more than two vectors. As you can see in this diagram here, there are 6 vectors named F1, F2 to F6. F1 is lying on the horizontal, while F3 is lying on the vertical, as you can see, while others are inclined at an angle to the horizontal or vertical. So that is what is explained in this note here. How do we now find the resultant of all this, even if there are more than this? We have to make sure we resolve all of them into two components, vertical component and horizontal component, which will be Fx and Fy. Then from there, we find resultant. How do we find resultant? That's what we are going to see next. All right, resultant of all the 6 vectors here can be found using this formula. So any number of vectors you are given, this will be the formula for finding the resultant after you have resolved all of them into vertical and horizontal. Summation Fx all squared plus summation Fy squared. Then you find the square root of the sum of their squares. Whatever you get is the resultant. How do you now resolve all this into vertical and horizontal components? That is what this table is explaining here. I want to explain to the best of my knowledge. All right. If you look at this F1, which is this, under the vertical component, I wrote 0. Under horizontal component, I wrote positive F1. Let me leave the negative and the positive signs for now. I'll come to that later. Why is it 0 here and why is it F1 here? It is 0 here because the F1 is lying on the horizontal. And when you find the resolution of any horizontal force into vertical component, it is always 0. And also vice versa. Look at this F3 also. F3 is lying on the vertical. See. So under horizontal, F3 becomes what? 0. While F3 remains F3. So take note of that first. Any vector that is lying on the horizontal will remain its value under horizontal component, while it becomes 0 automatically under vertical component. Any vector lying on the vertical axis or on the vertical line in any given question like this, like F3, it will retain its value under vertical component, but it automatically becomes 0 under horizontal. So take note of that. That's the first keyword. Now, any other force that is not, any other vector, because it might not be force in all cases, but we usually use forces in most cases. Any other vector such as F2, F4, F5, F6 that are at an angle, how do we take care of them? Fine. You have to decide whether you want to start with vertical or horizontal. Because the moment you get one part, that will lead you to the second side. So me, I want to start with vertical. Okay, if I want to resolve F2 here now to vertical, what do? I will just form a right angle triangle through the angle given. This is angle given for F2. So I will just form a right angle triangle with it. This is a right angle triangle now. So this side is the horizontal. If you look at it, it's parallel to this horizontal line. So that means this is the horizontal side. This is the vertical side. While the F2 itself is the hypotenuse. If you look at that right angle triangle very well. So definitely, if I want to resolve under vertical, I will take care of this side, which is vertical, and the hypotenuse, which is F2. And using your SOHCAHTOA, this is adjacent, this is opposite. So that means adjacent over hypotenuse, here and here. That is cosine. That is why I wrote F2 cosine beta. Can you see? For F4, this is the angle given. I will form a line to make it look like a right angle triangle as I did here through this angle given. So if you look at this one very well now, this side here is the vertical because it's parallel to this vertical. While this side is the horizontal. While the F4 itself is what? Is the hypotenuse. So if I want to resolve under vertical, I will take note of this and this. So this vertical is facing this angle gamma. So that means vertical is opposite to this gamma. While the F4 itself is what? Hypotenuse. And opposite over hypotenuse, that is sine. That is why I have sine gamma. F4 sine gamma. Okay? It's very simple. This is it. Sine gamma is equal to opposite over hypotenuse, which is F4. When you cross multiply, opposite, which is the vertical component here, will be F4 times sine gamma. So that's how you get everything. Okay, now to get F5 component under vertical, I will just draw a line that will make it form a right angle triangle. So if you look at this very well, this side is the vertical side to this angle, while this is the horizontal because this side is parallel to this and this is already on the vertical. So if I want to resolve F5 to vertical, which is this side, I will need this side and the F5 itself, which is the hypotenuse. And this side is the adjacent now because this side, which is parallel to this horizontal, which is horizontal side, is facing angle theta. So this is opposite here now, where this is adjacent. So adjacent and hypotenuse will give me cosine. That is why when you see F5, it is F5 cosine theta. Okay? Now, finally, F6. I will do the same thing. So vertical is facing angle alpha, which is opposite, and this F6 is hypotenuse. That is so opposite over hypotenuse. That's sine. That's why you see F6 sine alpha. So now, how do you now get the horizontal? Like I told you, once you get one side, I've gotten the other side. Fine. For the horizontal, if you have cos on the vertical, that means sine will be on the horizontal automatically. If you have sine under vertical, cosine will be on the horizontal automatically. So that's why once you do one, you get the other from it. If it is horizontal, you do first. Opposite will be under the vertical. That is either sine, cosine, or cosine, sine. Alright. Then about the sign. The sign is telling us the direction. I choose negative for any vector facing left side, while I choose positive for any vector facing right side under horizontal. Don't forget, horizontal has to do with either right or left. But for vertical, any vector facing up, that arrow is facing up, I choose positive for that. Any arrow that is facing down under vertical, I choose negative. So if you look at it, F2 is negative because if you look at F2, the arrow is facing down under vertical. And it's positive under horizontal because the arrow is pointing right under horizontal. It's as simple as that. If you look at F4, under F4, vertical, the arrow is facing down. That's why it is negative. Under horizontal, the arrow is facing left side. That's why it's also negative. It's because of my own chosen signs. Positive for right, negative for horizontal, for left under horizontal, positive for upward, negative for downward under vertical. So finally, we will now add all this together. That will now give us summation Fy. That is 0 minus this, minus this, minus this, plus this, plus this. Whatever we get is our summation Fy. Plus F1 plus F2 plus 0 minus F4 cos gamma minus F5 sin theta plus F6 cos alpha. Whatever we get will be our summation Fx. Then from there, we apply this formula to find the resultant. So in the next video, we are going to see how to apply this in solving problems.